Okay, for this first question, it says that Hector's Service Club is raising money by wrapping presents in the mall. The function f of x equals 3x describes the amount of money in dollars that the club will earn for wrapping x number of presents. They only have enough wrapping paper to wrap 1,000 presents. So if you are struggling with this concept, the first thing that you need to do is make sure you know if we're talking about domain, we are referring to x values. We are referring to the input of a function. So we need to, before we can answer any questions about this domain, we need to know what the domain is. When they give us the equation, it's way easier because you can see where the domain is. It's this x number. And they even told me in this particular example that the x's, which are my input, represent the number of presents. So then you need to determine, is it discrete or continuous? If you're struggling with the concept of discrete or continuous, my suggestion is to ask yourself 3 questions. The first question is, can I plug in a 1? So yes, I can plug in a 1. It would represent the cost of wrapping 1 present. The second question, can you plug in a 2? Yes, it would represent the cost of buying 2 of the presents. Then you have to ask yourself if you could connect those dots, meaning on your graph, if you plugged in a 1, you should get a point at the 1. And then if you plug in a 2, you'll have a point at the 2. And we need to know, do I connect these dots? Or am I not connecting the dots, which would make it discrete or discontinuous, the D words going together. So if I am thinking about this scenario, I can pay to have 1 present wrapped. Yes. I can pay to have 2 presents wrapped. Yes. How about in between? Can I connect the dots? No, there are no numbers of presents between 1 and 2 presents. Even if the present is very small, it's still a present. So you would still have to pay what appears to be about $3. If I plugged in 1, I would pay $3. If I plugged in 2, I would pay the $6. And so it does not appear that I can connect the dots, which would make this discrete. I'm just going to put D for discrete and C for continuous. Now, under that little sort of half dashed line there, I'm also supposed to indicate if this is linear or exponential. If you're struggling with that, you can make yourself, excuse me, a little table. And if I were to make a table, my X's would go here, my Y's would go there. If I bought or I paid to have 1 present wrapped, it would be $3. If I paid for 2 presents, it would be $6. 3 presents, it would be $9. You can see that the pattern here is an arithmetic pattern. I keep going up by 3. So if I'm going up by 3 by adding 3 each time, that is an arithmetic pattern and it will be represented by a linear function. So I'll just put L for linear. Okay, so since we know it is discrete, the set notation is actually the only notation that I can use. And that's because these two can only be used for continuous. Not for discrete. So now I am going to write my set builder notation. It always starts out the same way. What letter are you describing? I am describing my domain, which is being represented by the letter X in this problem. After you say what letter you're describing, you put this little line where you're about to describe it. So I'm describing the set of numbers that are going in for the letter X, such that, and then you first describe it by saying what set of numbers it is an element of. So remember, for our discrete values, the discrete options are the natural numbers, the whole numbers, and the integers. For continuous, it is the all real numbers. I'll try and make those like double line things that I'm not very good at, but I just messed up the N. You get it. There we go. Okay, so now in this example, since I could buy 0 presents and it would cost $0, I can include the 0. Could I include negative values though? No, negative values wouldn't work because you can't buy or pay to have negative presents wrapped. So this would not be the integers or the z because that would include negatives. It would though be the whole numbers. Now, the whole numbers start at 0, and then they go 1, 2, 3 after that. However, I can't let them go on forever because remember the very last sentence, they only have enough wrapping paper for 1,000 presents. So if they only have enough for 1,000 presents, and X is representing the number of presents getting wrapped, I need to make sure that the number of presents getting wrapped X is either less than or it could be equal to the 1,000. Because they don't have any more wrapping paper beyond that.